Welcome students. In this lecture we are going to learn about Cauchy's residue theorem. This residue theorem helpful for evaluating the complex integration problem in a very easy manner by knowing the poles of the function. Cauchy's residue theorem states that if f of z is analytic at all points inside and on a simple closed curve C, except for finite number of isolated singular points Z1, Z2 and so on up to Zn inside the contour C, then integral over C f of z into 2 pi equal to integral over C f of z into dz equal to 2 pi I into sum of the residues at the points z equal to Z1, Z2 and so on up to Zn, which are lying inside the contour C. So we have to by heart this formula: integral over C f of z into dz equal to sum of the residues into 2 pi I. Consider this problem. Evaluate integral over C cos pi z square divided by z minus 1 into z minus 2 into dz, where C is mod z equal to 3 using Cauchy's residue theorem. The same problem you can solve it with the help of Cauchy's integral formula also. Now we are going to learn how to solve this problem by making use of Cauchy's residue theorem. Residues means you have to find out the poles of the function first. So singular points are by equating the denominator to 0, z equal to 1 and z equal to 2. Since the power of z minus 1 is 1 and the power of z minus 2 is 1, you can call z equal to 1 is a pole of order 1 and z equal to 2 is also a pole of order 1. Here the order depends upon the number how many times get repeated. So z equal to 1 is repeated only one time. Z equal to 2 is also occurring one time. Therefore, the other name of these poles are simple pole. Now we have to check out whether these points lies inside the contour or not. Because over this contour only you are going to evaluate it. Mod z equal to 3 is referring the circle x square plus y square equal to 3 square. So consider the circle with center 0, 0 and radius is 3. Mod z equal to 3. So this point is 3, 0. Now you have to observe that z equal to 1 lying inside or not. Absolutely z equal to 1 lying inside, because this is the point at z equal to 1. So it referring the point 1, 0. Likewise, z equal to 2 is also lies inside because it is referring the point, okay, 2, 0. Since the radius of the circle is 3, okay, definitely these 2 points lying inside the circle mod z equal to 3. So 2 points lying inside. Now we are going to see how we are going to evaluate by making use of Cauchy's residue theorem. Here at the point z equal to 1, this is a simple pole. So what is the formula? Limit z tends to 1, z minus 1 into f of z. Here f of z is cos pi z square divided by z minus 1 into z minus 2. So before applying z tends to 1, you have to cancel these two common terms, otherwise you won't get the answer. you will get the answer as indeterminate answer. So before applying z equal to 1, before applying z tends to 1, you have to cancel these two common terms. Then put z equal to 1 here. You will get cos pi divided by 1 minus 2. We know that cos pi is cos n pi is minus 1 to the power n and sin n pi is 0. So you are going to have minus 1 divided by minus 1 which gives you 1. Hence the residue at z equal to 1 is 1. Now similarly you are going to find what is the residue at the pole z equal to 2, which is a simple pole lying inside the contour C. So the same formula you are going to apply. Limit z tends to a, z minus a into f of z. Here a equal to 2. So you are going to have limit z tends to 2, z minus 2 into f of z. Okay. Here also you have to cancel these two common terms and then only you have to apply z tends to 2. So you will get cos 4 pi divided by 2 minus 1. Okay, already I have given the formula for cos n pi. Cos n pi is minus 1 to the power n. So cos 4 pi will give you positive value 1 divided by 1. The answer is 1. Therefore, integral over the contour C cos pi z square by z minus 1 into z minus 2 into dz is going to be reflecting integral over C f of z into dz, which is equal to the formula is 2 pi a into sum of the residues. Here two residues we have found, r1 plus r2. The values of r1 is 1 and the value of r2 is also 1. So 2 pi I into 1 plus 1 gives you 4 pi I. Now next we'll move on to the second problem. Evaluate contour integration sin pi z plus cos pi z square divided by z plus z square, where C is a circle with small z equal to 2. You can consider this also pi z square. Here I have given the hint. The poles of f of z are z equal to 0 and 1. Here, how will you get z plus z square equal to 0 implies z into z plus 1 equal to 0, or this gives you z equal to 0 and z equal to minus 1. Here z equal to 0 and z equal to minus 1 are simple poles, both lies inside the contour mod z equal to 2. Now evaluate what is the residue at z equal to 0 and what is the residue at z equal to 1. You will get the answer. Check it out. So how to find R1? R1 is equal to limit z tends to 0, z minus 0 into sin pi z square plus cos pi z square divided by z into z plus 1. So these two gets cancelled. Now put z equal to 0. Sin 0 is 0 plus cos 0 is 1 divided by 1. It gives you 1. Then for finding R2, R2 is limit z tends to minus 1. It is a simple pole only. So the same formula you are going to apply. Z minus of minus 1 will give you plus 1 into sin pi z square plus cos pi z square divided by z into z plus 1. These two gets cancelled. Put z equal to minus 1. So sin pi plus cos pi divided by minus 1. Okay. Sin pi is 0. Cos pi is minus 1. Minus 1 by minus 1 will give you plus 1. Okay. Hence R1 equal to 1 and R2 equal to 1. By substituting in the formula, sum of the residues 1 plus 1 into 2 pi I will give you 4 pi I. Next, we'll see this problem. Evaluate the integration over C, z square into e power 1 by z into dz, where C is mod z equal to 1. So what is f of z? F of z equal to z square into e power 1 by z. Here, by equating 1 by z equal to 0, that is the denominator you are having e power 1 by z. So put z equal to 0 here. This is the only singular point and it lies inside the contour mod z equal to 1. It is a unit circle. That means circle with center 0, radius 1. So therefore, here z equal to 0 occurring only one time. So it is a simple pole which lies in mod z equal to 1. Now to evaluate this by making use of Cauchy's residue theorem, we have to get the residue at the point z equal to 0 which lies inside mod z equal to 1. So before that, since the function is given in this form, we are expanding the power series. We know already the formula for e power 1 by z. It is 1 plus 1 by z plus 1 by 2 factorial into 1 by z square plus 1 by 3 factorial into z cube, etc. Multiplying z square inside, you will get z square plus z plus 1 by 2 factorial plus 1 by 3 factorial into 1 by z, etc. Now what does the formula says for residue of f of z at z equal to 0 is, since it is a simple pole, we are having the formula limit z tends to a, z minus a into f of z. What is a here? 0. So limit z tends to 0, z minus 0 into z square into e power 1 by z. Already we know what is z square into e power 1 by z. Substitute this here and multiply it with z. You will get z cube plus z square plus 1 by 2 factorial into 1 by z plus 1 by 3 factorial into 1 plus 1 by 4 factorial into 1 by z, etc. Now, applying z tends to 0 here, you will get this term is 0, this term is 0, okay? And 1 by, here, you are having 1 by z. Here, you will have 1 by 3 factorial, okay? You have to consider only these terms, okay? Therefore, here you will have 3 factorial gives you 6, 1 by 6. So hence by Cauchy's residue theorem, integral over C f of z into dz equal to 2 pi a into sum of the residues at z equal to a. Now you will get at z equal to a is 1 by 6. Therefore, you will have 2 pi a into 1 by 6 which gives you pi a by 3. We'll see similar problems based on this. See here, evaluate integral over C tan z into dz where C is mod z equal to 3. See this tan z we can write it as fraction form like sin z by cos z. Consider that function as p of z by q of z. Now find out what is the singular point. For finding the singular point, you have to equate cos z to 0. That gives you z equal to cos inverse of 0. Cos inverse of 0 is pi by 2, 3 pi by 2, 5 pi by 2, etc. Plus or minus also you can take because cos of minus theta is cos theta itself. So you are going to have plus or minus 2n plus 1 into pi by 2. Now by putting n equal to 0, you will have plus or minus pi by 2. We know pi value is 3.14. So 3.14 divided by 2 will give you 1.57. So definitely you can see that mod z equal to 3. mod equal to z equal to 3 means what? It is a circle with center 0, 0, radius is 3. Okay, mod z equal to 3. So the point 1.57 definitely lies inside the circle. Okay, lies inside the circle, z equal to 1.57. Likewise, z equal to minus 1.57 also lies inside the circle. So at these 2 points, you are going to find out the residues, and they are simple poles because they are occurring only one time. Okay, so z equal to plus pi by 2 and z equal to minus pi by 2, they are lying inside the contour mod z equal to 3, and they are simple poles. And here f of z we are considering it as rational form p of z by q of z. So the formula is what? Limit z tends to a, p of a divided by q dash of a. So a is here pi by 2. For finding the residue of f of z at z equal to pi by 2, put a equal to pi by 2, it will be what? P of pi by 2 divided by q dash of pi by 2. So in that case, you no need to find, you no need to write z tends to pi by 2. Okay, if you want to write z tends to pi by 2, let it be limit z tends to pi by 2, p of z divided by q dash of z. Okay, so here by putting p of pi by 2, okay, here what is p of z? P of z is sin z. What is q of z? Cos z. What is the derivative of q of z? Minus sin z. So put z equal to pi by 2, sin of pi by 2 divided by minus sin of pi by 2. These two gets cancelled, you are having minus 1. Similarly, I have to find residue of f of z at z equal to minus pi by 2. So what is the formula? Same formula you are going to get limit z tends to minus pi by 2 p of z divided by q dash of z. Okay, so substitute the values. P of z is sin z and q dash of z is minus sin z. So these two gets cancelled. You will get the answer as minus 1. Hence, by Cauchy's residue theorem, integral over c f of z into dz equal to 2 pi a into sum of the residues of f of z at z equal to a. So here two residues we have found out. R1 is minus 1, R2 is also minus 1. Therefore, by adding those two and multiplying it by 2 pi a, you are getting the answer as minus 4 pi a. This completes all possible problems based upon the Cauchy's residue theorem. Hope you all understood. Thank you.